Hello, let's talk about statistics. So let's say I have 10 students in my classroom and each of them students is given an index I. This means nothing, just a number, student 1, 2, 3 all the way to 10, and xi is the grade of the student. So one thing that one is interested in is what is the average or mean of the population of this test. So as you know, the first thing we need to do is add together all the grades of all the tests from the students, and this should give us 861. Now, to find the average or mean of this test, all I have to do is divide the total score, 861, by the number of students, 10. So the average of this test is 86.1. We note this usually with an x average. Okay, so of course the rule is that the x average equals the summation of xi from I equal 1 up to n, where n is the population that we have divided by n, the number of students in this case. So let's have a look. 86.1 is the average score, but if you notice, most of the students did a lot better than this. Actually, all these 8 students did better than 86.1. So why is the average or mean so low? Well, because of these 2 students. The grades is so low that it is pulling down the average. So that's why we have another number that we use to describe the grades, and this is the median number. What is the median? Well, the median is very easy to find. We start writing all these numbers in increasing order. Okay, so the lowest one is 50. Okay, the next one is 85. Okay, then we have 2 87, so I have an 87 from this student and an 87 from this student. Next is 89, 90, 91, 92, and then 2 95s. 95. So if we did this right, we should have 10 numbers. 4, 5, 6, 7, 8, 9, 10. That's correct. So median is the number in the middle. So in this case we have 10 numbers, so there's no single number in the middle. Instead, we have 89 and 90 in the middle. Have 4 numbers on the left and 4 numbers on the right. So we'll take the average of these two. If we had an odd number of samples, then we just take the one in the middle. In this case, it will be 89.5. So this is the median of this test, 89.5, which is a lot higher than 86.1 that the average value was. So the grades follow what we call a Gaussian or standard distribution. This means that if on the horizontal axis I have the grade x, and on the vertical axis I have the number of students, okay, I expect on near the average grade, in this case the 86.1, to have a lot more students than further away from the average. The standard distribution looks something like this, like a bell curve, okay, and it's important for us to know how wide this curve is. To calculate the standard deviation, we'll use two formulas. So if all the students in our class are 10, then the standard deviation can be calculated as sigma equals square root of summation xi minus x average square divided by n. This means that we need to add another column here, the xi minus x average square, and for each student's grade find this quantity. So here we'll have 50 minus 86.1 square. Here we'll have 85 minus 86.1 square, and so on, and then we're going to sum all these numbers here and use this number here to find the standard deviation. But if our class has more students and this is just a sample of papers, then the standard deviation will be calculated as sigma equals square root, again, summation of xi minus x average square over n minus 1, where n in both cases is the population number. Just in the second case, it's the population sample number, these 10 sample papers we took out of how many students we have in total. So for this example, let's assume that these 10 students are just a sample of a larger class, of a much larger class. So we're going to use this rule for the standard deviation, okay, and then this will equal square root of 1546.9 divided by 10 minus 1, and this should equal 13.1. So now what does this mean? It means that plus or minus 1 standard deviation from the average, we have 68% of the students. So the average 86.1, here we have 86.1 minus 1 standard deviation, so 13.1, that should equal 73, and plus 1 sigma means 86.1 plus 13.1 equals 99.2. So within this grade range, I should have 68% of the students taking this course. If we extend this range to the average minus 2 sigma, so now that's 86.1 minus 2 times 13.1, this equals 59.9, and plus 2 sigma, we go to 112.3. Let's assume there's such a grade for this exercise. So within this range now we have 95% of all the students. And if we change this range even further, adding 3 sigma and going to 125.4, which is 86.1 plus 3 times 13.1, and then subtract 3 sigma, and go to 46.8. Within this range I shall have 99.7% of all the students.